Okay, so let's start with the left triangle. Basic triangle. Okay. We know the base, we know the height, so we simply apply area equals 1/2 base times height. We've done that a gabillion times. I don't need to spend any more time with it. However, I did want to point out this pink triangle creates some problems. Why does it create some problems? Well, hold on. Before we talk about the pink triangle, let's go back to the blue triangle. Do you all realize that there are actually 3 different ways I can calculate the area of that triangle? Right? It's not always sitting on the base. In other words, I could do this. Make this, let's call that H2, and make this B2, and calculate the triangle that way. Okay, I can spin that triangle around. As long as I know one of the sides and the perpendicular height to it, I can solve for that. I can also do it the third way by doing this. Now we've got H3 and B3. Okay, just for giggles, let's see who's learned anything. What's that point called? Which one? Orthocenter? Are you sure? Do you agree? What are you counting, Brody?
I was remembering the 3 other.
What are the 3?
Orthocenter, circumcenter, and centroid.
And which one is that?
Orthocenter.
It is the orthocenter, yeah. But irrelevant. But 3 different ways to calculate the triangle, area of the triangle. Now, the same thing happens over here. I can do it 3 different ways, but realistically speaking, what we're going to be concerned about is this height. The height doesn't need to be inside the triangle. It can be outside the triangle. However, this is just the base. We exclude that part there. It's not needed. Okay, so if you think about if you're a little bitty person standing up on top of this triangle thing, the height is going to be the distance that you can drop a ball down. Standing up on the top of this triangle over here, gave you long hair and a skirt. And when you drop the ball, it falls straight down along the height. Okay, so there's nothing new there. We've done that before. Easy peasy. Questions? No? Great. Let's learn 2 new methods. We'll come back to the equilateral triangle because that one's easy. Let's start with that yellow guy. So the yellow guy is the scenario that, well, let's just go. What's the relationship between A and H? Aardvark and hippopotamus.
A is H times the square root of 2.
Nope. Because we don't know it's a 45, 45, 90 triangle nor a 30, 60, 90 triangle. Good guess. Oh, by the way, what's this thing called again?
Theta.
It's just, did you say theta or beta?
Theta.
Theta. It is a theta. Very good. Okay. So again, what's the relationship between A and H? About
A is bigger than H.
yes. That's a true statement. Why?
Because it's a right.
Yeah, I forgot to do that. Sorry. Okay.
A is the hypotenuse. A is
Okay.
bigger than H.
Good. What other relationships are there between A and H? That one went on, now that one went on. Some places go in the heck of hand basket.
I'd be free right now.
There's like close to the baby song that's the same thing. He's going on. He's treating us.
Little toilet.
Again, what's the relationship between A and H? I'm not giving you this, by the way. You got to come up with this one. Scott?
A times B equals H.
Nope. Good guess.
Oh, times 1/2.
Nope.
Is it like the hypotenuse?
It is. Keep going.
Well, I guess I could say like the bottom thing times H equals A squared, or, you know, like, well, it makes a right triangle.
It does. Keep going. What can you use in a right triangle? 2 answers to my question, by the way.
Pythagorean theorem.
Could use Pythagorean theorem, but that's not the route we want to go. Trig. Okay, so back to you now. Using trig, what's the relationship between A and H? You're going to have to use theta too.
Okay, so sine theta equals H over A.
Sine of theta is equal to H over A. Outstanding. Let's give it up for Amelia. Meg, what's the area of this yellow triangle? With the stuff I have labeled there. Not a trick question. Just give it to me.
The full 1/2 B times H.
Yeah. So the area of this guy is 1/2 B times H. Okay. Good. Now, excuse me. Now let's combine those two. If I take this equation that Amelia gave me and I solve it for H, I get A times the sine of theta is equal to H. We good so far? Now, take this and plug it in there. And we get this very handy formula that says area is equal to 1/2 AB sine theta. So what does that mean? Now notice if I get rid of all this other stuff, I get rid of this, I get rid of this, I lose the height. I don't even need this here anymore. Okay, so let's just move the B up here. Now you see, I have a nice, easy method for calculating the area of a triangle without having to find the height. Okay, so what are my requirements? My requirements are simple. I need to know 2 sides of the triangle, and I need to know the angle in between. We commonly call that a side angle side scenario. So if you have a side angle side scenario,
The side angle side scenario.
Mr. Levinson, everybody! Mr. Levinson! Come back! He's gone.
Side angle side scenario.
He's already on the 2nd floor. Okay. Side angle side scenario.
Yeah.
We're going to use that a lot with some of the stuff we're doing in the future. Questions? Okay, now yes.
So can you use the bottom right angle, or do you have to have the other side, like the?
2 sides and the angle in between.
Oh.
Okay. Now, let me clarify because this every year this gets weird. If I give you this problem, okay, let's say for instance I tell you A is 5, B is 7, and theta is 42 degrees. You just plug and chug. I get people all the time that go through this big calculation to get to this point. You don't have to. We did this to get this, so that now all you have to do is use that guy when you're doing calculations. Easy peasy? Good? Any problems? Okay, last scenario. Let me get some stuff out of the way here. Let's make this go away. Okay, and then we don't need this anymore. And this can go away. Okay, here we go. We've got an equilateral triangle. And we'll call the sides of that equilateral triangle S, because if it's equilateral, all the sides are equal. How big are the angles, by the way? 60, good, but it's irrelevant to the discussion. You could, if you wanted to, use 1/2 AB sine theta, right? So we know that's 60 degrees. If you're given one of the sides of the triangle, you could just simply do area is equal to 1/2 AB sine theta. In this case, it would be 1/2 S times the sine of 60, which again is 1/2 S squared times the sine of 60. Okay, that's one possibility, but I'm going to show you a different possibility. Change some colors here. Let's go with this. And get rid of that. Get rid of this. Whoa, that's a mess. Hold on. How do you find H? Wow.
Split S into
Okay. So if I'm understanding what you're saying correctly, this distance is how long?
half. It's half of S, so S divided by 2.
Okay. You want S divided by 2 or half S?
Half S.
Half S. Okay.
Then let's do like Pythagorean theorem, since it's a right triangle.
Beautiful. Two options, actually. You can do Pythagorean theorem, which I'll do in a second, or you can use a 30, 60, 90 triangle, yes? Okay. If we do a 30, 60, 90 triangle, how big is H?
H is
You might need some help here. 30, 60, 90 triangle. If you know the short leg, how do you get the long leg?
1/2 S times square root of 3.
Which one, 2 or 3?
3.
3, correct. However, you also said you wanted to do 1/2 S squared plus H squared equals S squared. Right? Okay, so that's 1/4 S squared plus H squared equals S squared. So H squared is equal to 3/4 S squared. So H is equal to the square root of 3 over 2 times S squared. Whoops, I lied. S, because I took the square root. I like the first method better. Notice that this number and that number are the same, just written differently. Did I lose anybody? Are we good to go? Smith.
How did you get 1/4 S squared for the second derivative?
I took 1/2 and squared it and squared the S. Because remember, you guys square everything in the parentheses. Okay. I'm going to get this out of the way. And now we're going to come back and do the area of this triangle. I don't need this anymore. I know that the base here is S. So the area of that triangle is equal to 1/2 times the base times the height. Which, when you clean that up, is S squared squared to 3 over 4. It's been a while since we've done trig. It's been a while since we've done 30, 60, 90 triangles. Notice that this equation and this equation are identical. How do I know that? Because you'll recall, or maybe you don't, but we figured out what the sine of 60 was by drawing triangles. The sine of 60 is the square root of 3 over 2. So if I plug the square root of 3 over 2 in here for 60, I would get the same formula. Okay. Again, all of this stuff in white and orange is a derivation of where this formula comes from. All you're going to do is plug and chug. Okay. Have you got all this? Can I move on to a new slide? We're good? Okay, so for instance, find the area. So we'll call this problem 1. We'll call this problem 2. Find the area of both of those, the blue and the green triangle. Does anybody know Prospect Parks is going today?
I think it is.
Okay. Question?
I have an answer.
For which one?
Both of them.
Hold on. Okay, Rebecca's going to help me with number 1, and Scott's going to help me with number 2. Rebecca, what'd you get for number 1?
21.22.
I don't know.
Units squared.
How'd you get that?
I did 7 squared times the square root of 3 divided by 4.
That?
Yeah.
Outstanding. And that's approximately how much?
21.22.
And you said units squared, right? Do you all agree?
Yes.
Yep. Wait. So Anna, you're shaking your head no. What's the matter? You do not agree?
No, I agree.
Oh, so why are we doing this? You're confusing me. You do agree.
I was confused, but like I get it now.
You're confused about equilateral triangle, right? So then we're going to use area is equal to s squared, square roots of 3 over 4, where s is equal to 7. Plug and chug. Okay. You can leave it in the form 49 square roots of 3 over 4, or you can multiply it out. I prefer a decimal answer, but I don't care. I can work with either one. Any questions for Rebecca? Beautiful. Scott, what do you got? Number 2.
70.41 units squared.
Can somebody confirm? Yes? Okay. How'd you do it, Scott?
I did 18 times
70.41, you said?
Yeah,
Units?
yeah, unit square.
Units squared. Good. Do not just give me answers. I want to see setups, where they came from. Okay. Questions? Easy, yes? This formula here, you will use a lot when you get into calculus. So that's something that you're going to want to burn into your brain. The nice thing about all of these problems is that if you have a brain fart and you can't remember this formula, you can always go back to calculating the height, use a 30, 60, 90 triangle, use Pythagorean theorem, do a lot of different things to find that. The 1/2 AB sine theta, however, that I erased, you're kind of stuck with. You got to know how to use that one. You don't want to have to go through and derive that every time. Okay. Good. Questions? I got good news and I got bad news. Which one do you want first?
Bad news.
Bad news. Quiz on Tuesday.
Good news.
Good news. It should be pretty easy. It's just triangles. Okay?
It's on this, right?
It's on paper. Okay. What else would it be on? Like your feelings? Yes, Guy, you have a question?
Wait, never mind.
Okay, glad I could help.